Guys, so today I'm going to talk about this problem, Stone Game's 7th. Alice and Bob take turns playing a game with Alice starting first, and then blah blah blah. Each of them are allowed to take either leftmost or rightmost uh, stone, and these stones have some values. And the goal of the game is to maximize the difference. So let's say the total sum of this array is something, and if Alice takes 2, then Alice scores the sum of the remaining stones. And then in the remaining stone, now it's Bob's turn to uh, pick one stone. So let's say he picks 5, then Bob gets a sum of the remaining values in the array. So at the end, Alice will obviously win, but the goal here is to minimize for Alice. The goal is to maximize the score that it gets compared to Bob, and Bob's goal is to minimize the score. That means Bob's goal in the remaining array is to maximize the goal. I mean, maximize the score that he gets. So how do we solve this problem? So you can go through this example where Alice picks 2 because 2 is the smallest in the this array, so he scores a sum of all of these values, which is 13. And in the remaining array, I mean, you could have thought that Bob would pick 4 because that's the minimum among left and right, but Bob picks 5 in order to maximize his score as well as minimize the score that Alice gets in the next pick. So instead of picking 4, he picks 5. So he scores 5, 608, which is the sum of this subarray. And in this subarray, Alice picks 3 so as to score 5, and then Bob picks 1 to score 4. And that's how the minimum difference is 6. So let's solve this problem. So, I mean, it's very difficult to get a straightforward solution route in your head, but let's start from step by step. So we can declare 2 variables, left one, and then we need to calculate the sum again and again. So let's calculate the sum. Now what we can do is let's write a function. This function should return the score difference between the maximum score that Alice can get and the maximum score that Bob can get in the remaining array. So let's pass the parameters right and sum. So this is all the parameters that the solution depends on. So let's start writing the function. Now let's try to solve the edge case. So let's say we have only 2 elements in the array, right? So that would be our edge case or ending scenario. So let's say if the array has 4 and 5 and it's anybody's turn, it doesn't matter, what will they pick? They will obviously pick the lowest value, so they will score the maximum element on that array, and that will be the end of it, end of the source, because the next step, this one will be picked and there is nothing to pick, and the score that the last person gets is 0. So we can make this uh, stage as the final pick. So if 1 equals to right, so this is the end state. So what we can do is we can return the score here, which is because the person will pick the minimum value so as to score the maximum value. So that means we can just return the maximum value here. Otherwise, what we need to do is we need to check, pick the left value and calculate the score. uh, this can be minimum or maximum. Optimum value, we need to check both, so pick the right value and score, right? So how do we pick the left value? So let's say score 1 equals to, when the person picks the left value, then he scores sum minus this is the score that the current person who is picking gets, but then we have to subtract it from the maximum value the other person can get in the remaining array, right? So this would be find stones, and we're picking the left one, so we have to increment the left. All right, so this would give us the total score difference that the current person gets when he picks the left stone. Similarly, if the person would have picked the right stone, what would the score be? Score 2 equals to right minus, and what would the other person would have got in the remaining array is left minus 1 minus, this is the score that the other person would have got. So we need to check which score is higher, and based on that, the current person needs to pick the left or the right stone. So the difference, this is actually the difference, so we can just return the maximum of these uh, differences. So this is our solution. So let's try to see if this worked in the first scenario. Let's test it in the second scenario. Still works. I think there is some optimization that we can do. Let's try to submit the solution. Okay, time limit exceeded. Because we have not optimized yet, we are calculating all the scenario again and again. So let's say it picks left and then it goes down. It can either pick left or right, but this one value, the optimal value between these left and right, could have been already calculated in the previous step. So let's memorize this. dp and dp equals to now what we can do is, if we have already calculated this part of the subarray, then we can directly remove return that value. If dp not equals to 0, dp right, otherwise we can memorize this. dp equals to this, still returns us the correct solution, but now it will avoid so many calculations, so the solution should be correct. Yeah, I mean there are some other optimal solutions as well, but this one works fine. Thank you guys for watching this video. See you guys in the next video. Bye bye.